We will now do questions on ultrasound. But before we do that, we will discuss what are the theory and the formula that we need to know. The theories. We need to know the production and the detection of ultrasound. Note that ultrasound imaging uses frequencies of sound above the human hearing range. Ultrasound is created and detected by piezoelectric crystals. Then you must understand how ultrasound is used as an imaging tool. Ultrasound pulse is directed into the body. The time and intensity of the reflected pulses are converted into an image to provide diagnostic information about internal structures. Then you need to know the formulas and that you have to remember and then use in the calculation. There are three formulas you need to know. Number one is you must be able to define acoustic impedance of a medium as the product of the density of the medium and the speed of the ultrasound in the medium. Then you must know the formula for intensity reflection coefficient alpha. And what is it used for? Then number three, we need to know the attenuation formula, which is I equals to I naught, I0, e to the power minus mu x for the attenuation of ultrasound as you go through a substance. In this question from May-June 2010, variant 4.2, question 11, we need to explain the main principles behind the generation of ultrasound to obtain diagnostic information about internal body structures. The transducer used is the piezoelectric crystals. Then the two opposing sides of the crystals is coated with silver so that they can act as electrodes. Well, silver is a conductor of electricity. Then number three, the crystal is cut so that the crystals will vibrate at a natural frequency larger than 20 kilohertz. Number four, an alternating potential difference with a frequency in the ultrasound frequency region is applied across the crystals, causing the crystals to vibrate. Number five, resonance occurs because the frequency of the applied potential difference is equal to the natural frequency of the crystals. Then last point, this causes the crystals to vibrate at resonant frequency with maximum amplitude to produce ultrasound. In this question from May-June 2009, paper 4, question 11, part A, explain the main principles behind the use of ultrasound to obtain diagnostic information about internal body structures. The first thing I must say is the pulses of ultrasound is sent into the body. Then the ultrasound is reflected at the boundaries between the different tissues. Then the reflected ultrasound is received and detected by the same transducer, which is the piezoelectric crystals. The received signal is processed and displayed. The time between transmission and receipt of the pulse gives information about the depth of the boundary. And then the reflected intensity will give information about the nature of the boundary. In part D, data for the acoustic impedances and absorption coefficient of muscles and bones are given in figure 11.1. So these are the values given. And then the intensity reflection coefficient formula is also given. The attenuation of ultrasound in muscle follows a similar pattern relation to the attenuation of X-rays in matter. A parallel beam of ultrasound of intensity I enters the surface of a layer of muscle of thickness 4.1 centimeter, shown in this diagram here. So this is a muscle, this is a bone, and this is a boundary between the muscle and bone. The ultrasound will have to travel a distance of 4.1 centimeter in the muscle before reaching the bone.